Welcome to my YouTube channel. Today we will start with the topic which we have done last, and in this case we will do the next question based on the same topic. And in the last video, that is a part 1, and this would be a part 2. In part 1, what we have done, that what is the Cauchy linear differential equation, and how can you solve these Cauchy linear differential equation. And today we will go on a second part in which we will do another question based on the same method. So again, Cauchy differential equation comes on a differential equation with variable coefficient. Now the question is given on a screen, that is x square d square y by dx square plus 2x dy by dx minus 20y equal to x plus 1 whole square. So let's do. First of all, we will write it down this equation in symbolic form. So we know that we can write it down d as d by dy, d by dx. So how could we replace it? So if we want to replace it, first of all, we will write down here that is d square x square d square 2xd minus 20. Y is taken as a common. X plus 1 whole square. As I told you in last video that if it is a differential equation with variable, then what we will do here, we will replace our x square d square by theta into theta minus 1. X into d is replaced by theta, and we will put in this case e raised to power z, that can be taken as x, and log of x equal to z. These things we will try to put. And now see, we will put that is x square d square, it is theta minus 1. Then the next would be a plus 2xt. So it can be taken as 2 into theta. Then last one is minus 20. That would be a y. Again it is x is e raised to power z plus 1 whole square. So if we will go with this, we will take here that theta can be taken by d by dz. So if we want to solve it, again we will take here theta square minus theta plus 2 theta minus 20 y. So it can be taken as ez plus 1 whole square. Then we will write it down theta square plus theta minus 20. Then y, it is e raised to power z plus 1 whole square. Now we know that this is a non-homogeneous equation. So if it is a non-homogeneous equation, how can we solve this type of equation? We have to find complementary function, and with this complementary function we have to find particular integral also. So firstly we will find complementary function. To find complementary function, we will write down auxiliary equation. Now see, how can we write down auxiliary equation? That coefficient of y must be equal to 0. It can be taken as theta square plus theta minus 20, that would be equal to 0. We have to factorize it. Theta square plus 5 theta minus 4 theta minus 20 equal to 0. Then theta plus 5 minus 4 theta plus 5 equal to 0. Again we will take here theta minus 4, theta minus 4, then theta plus 5 equal to 0. So theta can be taken as 4 and minus 5. So its complementary function can be given by y c e raised to power 4z plus c2 e raised to power minus 5z. So again c1 e raised to power 4 log of x plus c2 e raised to power minus 5 log of x. So it is c1 e raised to power log x raised to power 4 plus c2 e raised to power log x raised to power minus 5. So it can be c1 x raised to power 4 plus c2 x raised to power minus 5. This thing is known as solution of complementary function. Now let us go for finding a particular integral. To find a particular integral, it can be taken as theta square plus theta minus 20 y, that would be equals to ez plus 1 whole square. How can we find complementary function? How can we find particular integral? So it can be taken as 1 by theta square plus theta minus 20. If I want to go back, yeah, theta square plus theta minus 20. So how can we solve it? It is a plus b whole square, a square plus b square plus 2ab. Then we can separate it out. 1 by theta square plus theta minus 20 over e raised to power 2z plus 1 by theta square plus theta minus 20 over 1 plus 1 by theta square plus theta minus 20 over 2 into e raised to power z. So firstly, we know that if we have e raised to power alpha x, in the last cases we have done that d is replaced by alpha. Now in place of d we have theta, so it simple means that theta is replaced by alpha. The value of alpha in first term is taken as 2. So it means that we will write down 1 by 2 square plus 2 minus 20 e raised to power 2z plus again, how can we write it down? It is 1. Can I replace it by e raised to power 0z? So it means that 0 square plus 0 minus 20 e raised to power 0z. Then if I will move further, then it is plus 1 by 2 as it is e raised to power z. It means 1 square plus 1 minus 20 e raised to power z. So if I want to simplify this equation, it may be a 1 by 4 plus 2 minus 20 e raised to power 2z minus, again here is minus 20. So 1 by 20 e raised to power 0z. Then again it's a plus, I think. It's a plus. It is again 2 times 1 plus 1. 2 minus 20, that is minus 18. So I'll write it down minus 18 e raised to power 6. So it means it is 6 minus 20 minus 14 e raised to power 2z minus 1 by 20, then minus 1 by 9 e raised to power z. Again we have done that. What can we replace by e raised to power z? It is log of x minus 1 by 20 minus 1 by 9 e raised to power log of x. So again minus 1 by 14 e raised to power log of x square minus 1 by 20 minus 1 by 9 e raised to power log. Again it should be a minus 1 by 14 x square, then minus 1 by 20, then minus 1 by 9 into. So now this is the value for our particular integral. As we know, we have already find it complementary function, we have find its particular integral. Now how can we write it down complete solution? So the complete solution is complementary function plus particular integral. So if I want to go, what is my complementary function? It's c1 x raised to power 4 c2 x raised to power minus 5 c1 x raised to power 4 c2 x raised to power minus 5 minus 1 by 14 x square minus 1 by 20 minus 1 by 9x. So this is our complete solutions. Thank you very much.